This is our fourth webinar and our third related to software modernization. And we previously checked on the reasons to modernize or why not to modernize, major routes that can be followed in this process. And today we're going to deep dive into the reuse route or partial legacy software modernization. If you haven't seen our previous webinars, I invite you to check our YouTube channel where the recordings are available, and some of the topics we previously touched have more details in there. Um, let's start with the introduction. My name is Mihai Nagoye, and I'm an operations manager within Wayfair with a background in software development, mainly using Progress, OpenEdge, and related technologies. Um, a short introduction on Wayfair. As you can see, we have more than 11 years of experience as a company with more than 100 talented team members. Throughout these 11 years, we have collaborated with more than 50, I would say, happy customers, out of which 19 are still active in our current projects. Our core technologies evolve around Progress technologies, and web technologies. A large number of our projects being focused on the modernization from Progress UI to modern technologies, Angular and React to be more specific. We'll check in our business case section more on the details for setting up this type of project and the technologies used. Our growth is organic. We're putting a lot of effort into raising new talents that join us from the university. Actually, we have two major universities in computer science field, which are an asset in Cluj-Napoca, our location. And speaking about our location, Cluj-Napoca is the major city in Transylvania. This is part of Romania. We're proud that Cluj-Napoca is one of the first cities, not only in Romania or Europe, but in the entire world to initiate the adoption of a net zero city action plan. The Net Zero City Action Plan is a blueprint for making the transition to carbon neutrality by 2030, and of course, to raise the parking fees in the city center. Working on the agenda for today, we'll make a short introduction on today's subject. We'll present our framework to start up the modernization project. We'll share two of our business cases which may be relevant for the reuse route. And we'll have a short section for some of the insights and the techniques useful in the modernization process using the reuse route. To recap, we all know what legacy code is. This is code older than 24 hours. And because of that, we have some challenges we need to overcome in modernizing this code. Such challenges are outdated technology, security risks, and most of the time some unhappy users, because everyone knows how important it is to do this step and start the modernization because of, to increase agility, reduce maintenance costs, avoid security risks. We'll jump right into the modernization strategy we want to showcase. In our previous webinar, we identified three major routes to software modernization: rewrite, replace, and reuse. You can find more details on that in those webinars. They're available on our channel. The route we're showcasing today is on the reuse, and while reusing the old code has its benefits and can speed up the development process, we need to make sure it does not strike back and puts more roadblocks in our efforts to create a new application on top of the legacy one. Partial modernization strategies involve updating or reusing certain aspects of existing systems, infrastructure, or processes while retaining other elements. There are several ideas on how to implement this, such as legacy system integration, component-based development, containerization, data modernization, user interface modernization, open source adoption, hybrid cloud adoption, and so on. And if we're talking about reuse, the best showcase is that I'm going to reuse some of the slides from my previous webinars, like in this case. Yeah, I have to admit, our framework hasn't won any pricing competition, but did prove itself valuable in providing the steps needed to start the evaluation of the complexity for several modernization projects. And because everything useful needs to be simple, we defined 4 steps: discovery, assessment, pilot, and evaluation. Discovery. This is usually a 2-hour session where we identify the challenges and needs of the project. As outcome of this, we'll be able to define the team and the skills needed for the assessment. Assessment. Here we have several sessions, each of 2 or 3 hours, which should cover both the functional and the technical challenges of the project. The output of this session is to define the strategy that will be followed on the project execution and define technical skills that would best fit on the pilot, which is our next step in the framework. We usually propose a pilot for both technical solution as well for the collaboration between the client and the team. This is a step that usually takes 2 to 4 weeks, up to 2 to 4 months, depending on the complexity of the implementation defined in the technical documentation. The output should be a production-ready set of features, and most of the times, for the pilot, an actual screen is developed. Finally, we have the evaluation of the pilot and the overall experience, which will result in a plan for next steps. Evaluation step provides feedback on implementation, but also on the collaboration aspect of the project between the development team and the business and key users. Once the project will kick off, we will recommend an agile approach with 2 to 4 weeks sprints, which will continue until the list of features is implemented and, of course, the modernization project is ready. We will dive now into 2 of our successful business cases involving software modernization with a reuse route, of course. This is implemented in 2 different domains. One is retail, where we have an open edge application, which is modernized, and a sports club, where we have an ASP.NET solution, partially modernized using this approach. Okay, a couple of words of our retail project case. We have a Belgium chain of retail stores specialized in footwear with a long history and over 200 shops in Belgium and more in the Benelux area. At the time we started this project, they already moved towards the new generation of shoppers and were starting to be active online and offline with some nice features like 3D food scanning and so on. Their main challenges in the business were which triggered the modernization process were related to moving their operations from offline to online. They had a Visual Basic application in the stores, which used the file share to communicate with the warehouse, so the stock and other operation critical values were not synchronized. They did not have a customer management system, and the data coming out of sales was not accurately updated. Just to make an idea on how the retail business has changed through the years, we can notice that the major change in which customer interact with the shops moved from the in-store channel to omni-channel, where a unified experience is mandatory. The technologies. Here we used the Progress-specific ecosystem. The client had the Progress Open Edge desktop application in the warehouse and the Visual Basic application in the stores. The purpose of the in-store application modernization was to remove the Visual Basic application and reuse the data and the APIs the warehouse provided as the central data was stored in the Progress database. Long term, the purpose was to move entirely the desktop application towards web in 2 steps. We defined some rules that were used throughout the modernization process. We will reuse the information from the legacy database. The new application with customer information will use the old data until that was migrated as well. For for a way to transfer the data between the two databases, we used the message queue system we built in-house. We tried to use as much as possible the existing procedures, and we set a proxy call mechanism. And we built a web interface using Rolebase. That was a tool from Progress Pacific at that time. I think this is currently retired from Progress Suite. The architecture of the new application followed the OERA, Open Edge Reference Architecture, and it was structured using the different layers defined by the architecture. We have the database, we have the data access layer, the business service layer, presentation layer, and integration layer for service communication. The first step in this approach was to move the logic from the front end to the back end. This is a representation of the challenge, but most of the times this is the easiest. This is the most complex part of the modernization process. Being able to decouple the front end from the back end in a monolith application. We also have a view on the server setup. Here we use the load balancer between two servers, where one is active for the web application and the second was a failover server. However, we used both of these servers for asynchronous data processing and message queuing. Because PassOE wasn't available when we started, we used the Tomcat web server instance and the classic app server. This is to be able to expose the REST API as defined. During the modernization process, new tools arrived, so we were able to introduce PassOE as well. In a nutshell, this is the architecture of the old application. We can see the Progress graphical user interface on top. And we have the legacy code, which is a procedural Progress ABL. We have the classic app server and the OpenEdge database. Throughout the modernization process, we kept the one-way communication from the new application to the old application to the old code. We defined the shared or common area where different procedures includes datasets or temp tables were kept. And we had the message queue database, which stored record changes from legacy database. And through a batch process, we were sending the data towards the new database. Here is a small overview of the message queue we built. We had the triggers on the legacy database for create, update, and delete. And these changes were stored in the message queue DB, so it would be later processed asynchronously. This was done to have a good application performance and for data that was not required to be synchronized live. The target was near real-time processing at that time. Once the message was stored in the database, based on the type of the message, we would have a message processor, which would pick up the messages using a scheduled task. This scheduled task would run as low as 10 to 20 seconds to every couple of minutes. The message would then be processed in a dedicated, how we called it, worker, because someone needs to get the job done. And it's better to have a system than a human doing that. You can see we have an attribute worker, an article worker, price worker, and so on. Depending on what needs to be done with the data, we have defined the service name and the service address. This is usually the API address that will receive the data in a JSON format. We're planning to have a more technical presentation on this message queue approach. So if you're interested in this subject, please let us know and we'll prioritize this presentation. Some of the screens from the application. These are the screens in the Progress GUI application. And these are some screens from the Rolebase application. I'm just going to go through them. Yeah, and some print labeling, which was quite important for a retail store. In terms of project team and staff, we had a mixed team of 6 developers in Cluj and 4 developers from our client. We used the Scrum Agile methodology and 3 sprints with regular visits from both teams on site. Okay, our next business case is a sports club scheduling app. Here we use the APIs and modernize the web application. Um, Unfortunately, these shoes cannot go out and play. They're all tied up. Our client is US based. It's founded in 2009 and is the leading provider of full suite studio, gym, health, and wellness club management software and services. Their business challenge is to continue to be the market leader, expand the customer base, innovate in the domain area, and upgrade existing customers to the new version of the application. Okay, here the purpose of the modernization was to upgrade the existing ASP.NET scheduling app to a modern React interface using the latest technologies for better user experience, both on web and on mobile devices. In the initial application, we have an ASP.NET monolith application. We have mixed ASP pages with web MVC. This is composed of several modules such as messaging, reporting, support, payment, scheduling. Each module communicates with each other, and there is a direct communication between the application and the SQL database. Uh, in our transition towards the new application, the scheduling module from the old application was modernized using a new React.js application we called scheduling v2. The rest of the modules were kept in the ASP.NET application, and both applications would work in parallel and can send and receive data from the same database. The backend provided the necessary APIs, either in form of creating new ones or updating the existing ones. The goal for this is to replace the former module entirely and all the current users to migrate to the new application. React application was written in the first phase using JavaScript. Now we're in the process of migrating to TypeScript. Scheduling v2 communicates with the database through an existing web API. This is consumed by multiple applications, and communication is done through HTTP requests to web API. For the technology stack, we have a responsive React application. This is for desktop, tablet, and mobile. We're using React Bootstrap library and CSCC preprocessor. In the first phase, the development of the application was done using JavaScript, and then we started the migration to TypeScript because the TypeScript extends the functionality of JavaScript and introduces many advantages for the development. Application state was using React Redux. We have HTTP requests between scheduling v2 and backend web API. These are made using Axios client. This is a promise-based HTTP client, which is very easy to use. Application performance and error tracking. These are monitored using the Sentry library. Sentry automatically detects and notifies us of critical performance issues. We can trace every slow transaction to a poor performing API call. And JavaScript dates are manipulated using datefns library. This is simple, consistent, and modular toolset. In terms of accomplishments, we managed to ramp up a self-organizing team. We are part of the project startup for the architecture and tool selection. We migrated the application from ASP.NET to React, and we implemented, of course, the scheduling v2 application. Here are some screenshots of the application before and after how the application looks now. We have the scheduling v1, and then we have month view here, week view, and so on. Okay, as a project team, we have a 40-member with knowledge in web technologies, specifically in React. We have a Scrum Agile approach with 2-week sprints, and we're involved in the integration and deployment of the new module of the application. Some of the lessons learned from both projects highlight the importance of planning the approach, defining a clear vision, having the right expertise, together with the constant feedback and track of the project. Now, selecting the best technologies for migration, this involves a good evaluation of various factors to ensure a smooth transition and optimal performance post-migration. Here are some key considerations. Compatibility. This assesses the compatibility of the existing systems with the new technologies. Um, we have to ensure that the chosen technologies can integrate with the current infrastructure and applications. Scalability. Consider the scalability of the new technologies to accommodate future growth. Choose solutions that can scale with the business needs without significant rework or additional investment. Performance. Evaluate the performance of the technologies under consideration. You can take a look for benchmarks, case studies, performance metrics. Costs, of course, consider the total cost of ownership. This includes licensing fees, implementation costs, ongoing maintenance, support expenses, and so on. Security, ensure that the new technologies have robust security features and compliance with relevant regulations to protect data and the system. Vendor support. Assess the level of support provided by the technology vendor. Consider factors as responsiveness, expertise, availability for updates and patches to address issues and vulnerabilities. Interoperability. Evaluate how well the new technologies interact with other systems and tools within the ecosystem. Choose technologies that support open standards and APIs to facilitate integrations. Ease of migration. Consider the ease of migration from existing systems to the new technologies. Evaluate factors such as data migration tools, compatibility with existing data formats, own team knowledge, and availability of resources such as developers, migration experts, consultants, so on. Future roadmap. Assess the future roadmap of the technology vendors to ensure that the chosen technology align with the long-term business objectives. And user experience. Consider the user experience of new technologies for both end users and administrators. Choose technologies that are intuitive, easy to use, and require minimal training to maximize productivity and adoption. Yeah. By carefully evaluating these factors, you can select the best technology for migration. Just as a short example of technologies most used for progress upon edge application modernization, especially for UI modernization, I would have one or multiple selections from PASOE, application server, one of the OERA frameworks which are on the market, such as Smart Component Library, Quarix, Fluid, IMO, and some other progress-related tools. For the front end, most of the times the selection limits to the more known frameworks or libraries, such as Angular, React, or Vue. There are some techniques used to resurrect legacy code and integrate it in the ecosystem. Some of them are code analysis, conduct a thorough analysis of existing legacy code to identify reusable components and assess their compatibility with modern systems, refactoring and modularization. Refactoring, modularize legacy code to make it more adaptable and reusable. Breaking it into smaller, more manageable components. API development, create APIs to expose legacy functionalities, allowing seamless integration with modern applications while abstracting underlying complexities. Wrapper libraries, develop wrapper libraries or adapters to bridge the gap between legacy and modern systems, enabling communication and data exchange in a standardized manner. Incremental migration, implement an incremental migration approach where legacy functionalities are gradually replaced with modern equivalents, minimizing disruption and risk while maximizing value over time. While there are many aspects in covering such a large subject, we try to gather meaningful information from our expertise into this webinar. And we also want to thank our customers and partners for being with us for the last more than a decade. Um, yeah, if if there are any questions, we'll be glad to answer.
Hi.
Yep. Hey, Ioana.
For mobile apps, do you use a native technology?
I guess it's for the sports club
Yes.
project. No, we don't have a mobile native application. Our application is fully responsive regardless of the device. We're using React Bootstrap and a lot of hooks, customs, and from libraries. So we have a full responsive layout. React Device Detect is a very good library. To detect if the application is used on a mobile or on a tablet or so on. So we don't have a native application, and it wasn't a requirement in this case.
Okay, and was it difficult to migrate such a large project from JavaScript to TypeScript?
Well, the modernization is still the migration actually is still ongoing. It's we took the same approach as for modernization projects. We started with small and isolated components and migrated those ones, and we started the iterative approach. It's still ongoing. I think we're quite close to finishing that up.
Thank you. Another question. Do you use certain frameworks for testing?
Well, for the Open Edge, Progress Open Edge modernization project, we used the OA unit. This is a unit test framework that can be used to integrate and implement unit tests. And for the sports club application, we used the Playwright library, which is an end-to-end testing framework. So it generated all the tests for all basic functionalities of the application. But
Thank you.
because it's a pure front-end application, then we opted for this solution to have a test front-end to back-end. If that works okay.
Thank you.
Okay. Are there any other questions? No? Okay. Well, this concludes our session of today. I hope you have found valuable information that will help you finding the right strategy for the modernization of your application, or just to see other experiences. If you have any other questions, or if you want to plan an assessment with us, we're reachable by mail, by social media, or via our website. Thank you for your time, and see you on our next webinar.
Thank you